लिंक तो तुमने मुझे दी नहीं ना। लिंक किस पे भेजी है? किस पे भेजी लिंक तुमने? सेकंड वाला क्या? जाओ जाओ जाओ। Hello, I am audible. Hello, I am audible. Hello, I am audible. Hi, good evening, everyone. Okay, thank you. Thank you. So, okay, thank you. Good evening. Okay, so let me start today's session. So today is the first session, and in this session, my objective is to help you to understand not about the theory. Okay, my objective is to help you to think about the logically. This is very important. As you know that I am in this industry from last 11 years, and what problem I am facing, or basically if I say whenever my students are going for the interview, what is the expectation of the interviewer? Expectation of the interviewer is that they are not looking for a candidate who is having a theoretical concept, right? What he is expecting, he is looking for the person or a candidate who has a different approach. They want to give such a problem, and they are expecting the person who is sitting in front of him or her, they are expecting the different type of solutions, right? So there are two things. Let me start. There are two things. One is theory. uh, right. One is theory. Okay. Sometimes we call theory as a concept. Okay, please try to understand whatever is I'm going to teach you or whatever I'm going to mentor you. This is all based on my learning of last 11 years. I'm not going to create any unnecessary situation that okay, this happened, this happened, this happened. No, everything is in my mind. I understand what and how my students are basically face the problem, and how basically we help them to get a job. Okay, so there are two things. One is theory. We call them as a concept. Now the question is, okay, the another thing is logical, right? Sometime sometime many of the students asking, sir, how to make the logic, how to build the logic, how to develop the logic, or how should I become a logical? This is very important. So in our book, in our notebook, or in Google, or etc., there are a lot of questions are available. Okay, but those questions basically are basically you guys are solving with the help of some methods. Okay, for example, I am teaching to a 10th class maths to 20 students, right? At 20 students I am giving a solution and following some method. All my 20 students solving the same problem with the same method. There is no unique, there is no different solution. So this is called a following of method. But in digital, this is totally different. Try to understand. Digital is totally different from maths. in digital there also a method like K-map, pause, SOP, etc., like solving with the help of algebraic equations, formula, etc. Right? If we stop using this formula, okay, these algebraic equations, okay, or stop using the K-map. I'm not saying that K-map is not good. K-map is good. Okay, basically it's taught to solve the biggest issue, but according to me, how my students will become a logical? The question is this. So what basically I help uh, my students ki okay, how you will become a logical? So the concept is, if for us some time if we stop following the some methods like solving any problem with help of K maps, okay, or solving with any problem with help of any equations, right? Then see what happened. Okay, so this is what I have followed in last 11 years, and I found a drastic change in my students. Same thing I'm going to teach you. Okay, these things is not very tough, but yes, this is required a time. You have to give a time if you want to become a logical. If you don't give a time, if you don't have a patience, no one can help you to become a logical. There is no theory is available how to become a logical. The logical you can become with the help of hit and trial, by solving the things on a paper. Okay, either it take 2 hours or 2 days. You have to give the time to become a logical. Okay, so this is what I want to express here. So there is two things, one is theory and one is logical. Okay, and how these are connected in digital. Whenever you go for any interview, the first question, okay, you are from electronics, you know the analog or you know the digital. The first question is always on digital. Okay, people asking, okay, what is mux, what is demux, what is difference between mux and demux, how half adder is different from full adder, how half subtractor is different from full subtractor, what is 2s complement if in sequential, how d flip flop is different from t flip flop, etc., etc. Okay, so many of you are taking a digital as a theoretical subject, but this is not true. Digital is not a theoretical subject. Digital is a basically a 100% uh, practical domain. Okay, so how we are going to take up that practical domain? We have designed a curriculum in such a way so that you will get, or I can say you, it will create an interest in you. Okay, so digital. Let's start. So as we know in digital, the first part is gates. Sorry, I'm not going to touch K-map. I'm not going to touch anything like binary conversion, binary equation, etc., because I'm expecting you guys have cleared first year, second year, third year, fourth year, and you have a awareness on digital design. Okay, like what is gate and what is the truth table of gates. Okay, what are different type of gates, etc. Okay, so, but I will give you the brief idea about each and everything, right? In very brief. Okay. So, gate, what is gate? Basically, a gate is a component, okay, which has a multiple input, single output, and which performs following operations. Okay. For example, you have an AND gate. Okay. The symbol of AND gate is this, and the priority has been given to 0. Okay. Similarly, you have an OR gate. The symbol of OR gate is this, and the priority has been given to 1. Okay, then you have a NAND gate. Okay, the symbol of NAND gate is this, and again the priority started from 0 to 1. Okay, I will share the truth table also. NOR, the symbol of NOR is this, and priority start from 1 to 0. Okay, let me like let me make a truth table. A and 0 0 0 1 1 0 1 1. Okay, and or NAND NOR, XOR, XNOR. Okay, sorry, XNOR, right? So there are many questions. First of all, what is gate? Okay, how you're going to enter or how you're going to enter in an interview. Suppose that I'm taking an interview. Okay, I will ask what is gate, and the thing is that how you are replying, that is very much important. You have to reply in very simple way, that a gate is a component which has a multiple input and single output, and it's perform following operation. Like if we give priority to 0, then what? So the output of first 3 is 0 0, because if there is 1 0, output is always 0. Now in OR, for example, there is another gate we call as a OR. If we give priority to 1, the output is 1, like 0 1 1 1. Okay. Before that, these two gates, we have a one more gate, that is called NOT gate or inverter gate. So if we give 1, it will give 0. If we give 0, it will give 1. I'm not going in detail because I know you guys are aware of it. Okay. So this is a symbol of AND, this is a symbol of OR. Now, what scientists or what engineers want? Engineers want few more gates. What they have done? They have connected a inverter after a AND gate, it become a NAND. So the invert of AND gate is known as NAND gate. Invert of NOR gate is known as invert of OR gate known as NOR gate. And now what is XOR? Very important. People asking question, or if someone coming to interview to me, I ask the question, what is exclusive or why we use the word exclusive here? Why we are not using the word anything else instead of exclusive? Okay. So the question is here, what is the meaning of exclusive? Okay. So according to me, before coming to the exclusive, let first see here what is difference between all these four gates, that you are not seeing all the outputs are same. At least one is different here, one is different here, one is different here, and one is different here. None of the gates has a same output. Why? Because if the gate has the same output, then you can't make the different logic. Very much clear. Okay, so this is the one property of gate. Okay, now in exclusive OR. Okay, now the scientists or engineers decided to bring some more gates. Okay, so how they can get a few more gates? So what they have decided? Okay, when they have the two inputs are same, 0 0 and 1 1, they have given 0. Okay, and when two inputs are different, they have given OR, that is OR. So whenever the input is 1, output is 1. So this is your XOR gate, and the invert of XOR is XNOR 1 0 0 1. So here two properties of this truth table, complete gate truth table. One, you will not find all the inputs, sorry, all the outputs of of any out of any gate is same. Okay, you will not find all the output is same. And second, you will not find any of the output is same. Okay, see, two differences here and two differences here. Okay, so two properties of gates. First, the output of all the gate is not same. If it is there, then you can't make the different logics. And second, the output of any gate is not similar to the output of any other gate. In that case, if it has happened, in that case, you cannot achieve the different combinations, right? So two properties, right? Now, as you know, universal gates is NAND and NOR. Okay, so why we call a universal gates NAND and NOR? Because we can implement all the gates with help of NAND and NOR. Okay, so today, as I mentioned in the starting, that I want you to make a logical. ठीक है, मुझे आपको logical बनाना है. Now the question is, how should I make you the logical? Okay, this is the biggest challenge for me 8, 9 years back, 10 years back, that how should I make my students logical? This is the biggest challenge. So I will come to that. So, but before that, what is the implementation of gates with the help of universal gate? For example, this is a NAND gate and I want to make the AND gate. Okay. So solution is very easy. It is available in book. It is available everywhere. So this is your implementation of AND gate using NAND gate. Very easy. 0 0 1 1 1 0. Okay. So this is the implementation of AND gate with the help of NAND gate. Okay. 1 2. Now how this basically arise? Okay. How this basically we come to this? This is through a optimization technique and shorting of one gate. Okay. Now OR gate. Now I want to make the OR gate with the help of 9 gates. Okay. I know the solution. That is why I am making here. This is your OR gate. Implementation of OR gate with the help of 9 gates. Very easy. 0 1. So 0 0 will give 1 and 1 1 will give 0 and 1 0 will give 1. So as you know in OR gate, if you give 0 1, your output is 1. Okay. Then okay, one more thing I basically what is this actually? This NOT gate. This is actually a NOT gate, or I can say the implementation of NOT gate with help of NAND gate. So as you know that in NOT gate you have only single output and single input. So shorting of two input will give you the one input. Okay. Now XOR A and B. Now XOR. So this is your XOR basically. This is the implementation of XOR gate A and B using NAND. देखो मुझे पता है इसलिए मैं बना ले रहा हूं और ये आया कैसे, ये रिसर्च के बाद, ऑप्टिमाइजेशन के बाद ये प्रॉपर सोल्यूशन निकल कर आया है. लेकिन आई एम नॉट हियर टू टीच यू दिस. बेसिकली दिस इज अवेलेबल. ओके, आई एम नॉट गोइंग टू मेक यू लॉजिकल विद हेल्प ऑफ दिस कॉन्सेप्ट बिकॉज दिस इज ऑलरेडी अवेलेबल. ओके, but just to create a momentum, just to make the awareness. Maybe you guys don't know, I am sharing you the truth table of each gate. Okay, so one thing I forget to mention here, buffer also. If you give 1, if you give 1, your output is 1. If you give 0, your output is 0. So there are two gates which are the single inputs. They are inverter and buffer, and there are 6 gates which are the multiple inputs. They are AND OR, NAND NOR, XOR and XNOR. Okay. So if I convert into if I add one more NAND gate and I short it, then this will become a XNOR, and this is XOR and this is XNOR. Okay. So you have gate number 1 and gate number 2 or gate number 3 XOR and gate number 4 XNOR. Right. Okay. Now, as I mentioned, I have to make you logical. So how should I start? We will make our own AND gate with the help of 9 gates. Okay. we are going to make it our own AND gates with help of NAND gates, and that technique we call a hit and trial. Okay, hit and trial technique. So what is the advantage of using the hit and trial? What happened if I call someone for interview? Okay, if I ask some question to any candidates when, okay, I can give an example in other way. Okay, nowadays, recently a cricket match between all the nations. So there is one player who knows how to reply of each ball. Okay, before that he has practiced, right? If he has not practiced how to tackle the bouncer, how to tackle the offside ball, etc., etc., right? If the person or if the batsman don't know how to handle those balls, he can't survive in a pitch. Okay, the same thing happened here. I'm calling any interview. I am going for any interview, and I don't know what is the hit and trial. I don't know how to make the logic. I don't know how to survive in front of the interviewer. I'm not going to select, right? So many of the students, whoever is coming to me and saying me, ki, sir, I want to go in core, I want to become a Vilsa engineer, embedded engineer. So first question I ask, do you know gates? He say yes, or she say yes. Okay, then make a AND gate with help of NAND gate. So the person had designed either this, either this, either this, or either this. Then I ask, okay, from where you have designed or from where you know all these things? He say or she says, sir, I have learned this thing from my book or from my learning. Okay, very good. Now, if I ask him or her, design the AND gates with some other method. Okay, design the AND gate with some other method and without shorting. This is called shorting. This is called shorting. This is called shorting. Now, design the gates without shorting. Then silence, completely silence. He or she don't know what I have asked because he or she has not practiced, or he or she has is not aware of making the logic. The making the logic in programming or making the logic in gates totally different. In programming, you use the syntax and other things to make the or to write the code. But in digital, basically you have to practice something new, something different without help of any tool or without help of any syntax. Okay, so what is that? Let me explain. Okay, again I am writing here design design AND gate. Okay, AND gate AND gate without shorting, without shorting. Okay, with the help of NAND gates only, with the help of NAND gates. Okay, I hope everyone uh, I hope everyone is aware or everyone is okay with this question. So the question is design a AND gate without shorting and with the help of NAND gates. So how we are going to start? Let's take up. Okay. So before that, we will write a truth table of 0. This is a truth table of and truth table of NAND. Out 0 and out 1. 0, 0, 1 and 1, 1, 1, 0. Again, those who have joined recently, today class is focused on to make you the logical. Okay. In starting, I mentioned there are K maps. There are many methods. One is K map, one is conversion, one is some equations. Okay. So without taking the help of those things, right? You have to design the gates, or you have to design the circuit without taking the help of K-map or any other method available in a digital domain. Why? Because if you know the method, yes, this is important to solving the big problem. This is required for every engineer, either in job or in any solving the any competitive paper, that is required, not an issue. But again, how you will become a logical, then in that case you have to stop it using for some time and think some hit and trial logic, some direct indirect approach. Okay, so what I will do here, I will take simple NAND gate and I will start making some hit and trial logic, right? Like this. So I want I want 0 0 here and I want 0 here. Okay, right? So try to understand. I will make a such a circuit, right? And I am not worry about the number of gates, right? I'm not worry about number of gates. Like I can use any number of gates, 4, 5, 6, 7, 8, 9, 10, 11, any number of gates to make the logic of AND gate with the help of truth table of NAND gate. Again, I want to make a logic of AND gate with the help of logic of truth table of NAND gate. Okay, so let's start. 0 0 0 0 1. So आउटपुट चल रहा है NAND गेट का, ठीक है, आउटपुट चल रहा है NAND गेट का. द आउटपुट is of NAND gate, but the final output should be of AND gate. Try to remember this. 0 0 1. Now this 0 will come here. Now 0 and 1, it will become 1. Now 1 1 will give 0, and from here 0 0, and now I got something. So what I will do, I will make another AND gate. Okay, now 0 0. Oh, sorry. Now this 0 0 1, and now this 1 will come here. So I got the final output is 0. See, I am giving 0 0 and I am getting output 0. See here. Okay, don't worry about this. So with on the same circuit, you have to prove all four. On the same circuit, you have to prove all four. Similarly, like here, you have proven I can prove 0 0 0 0 1 0 1 0 0 1 1 1. Okay, on the same circuit, I can prove all four, but yes, this is designed already. Okay, if I am calling a two students for an interview, try to understand. If I am calling a two students for interview, the one person I have asked design a AND gate with the help of NAND gate. He had designed the same thing, and the second person is don't know the first method, but he know something hit and trial, something logical, right? And he started thinking like this. The interviewer will take interest because what he is finding in him, that the guy is not giving up. He has not said, sir, I don't know. Right? The person started thinking, and finally the person like me will select the such person. Okay. Now on the same circuit, let's see the output of 0 1 1 0 and 1 1. Let's take let me make the same circuit. Okay, I am making the same circuit again. Same circuit, no changes. Okay. Okay, and this A and B. Now I will give 0 1. Okay, 0 1 0 1 1 0 1 1 0 1 1 1 1 0. See, I got my second output 0 1 0 0 1 0. Okay, I got my second output. Correct. Now let's make a third circuit. Okay, where I should make. Okay, I am. Okay, I will remove this and I will make the circuit here. Right. See, this circuit is not in my design. Please try to understand. ये सर्किट मेरे डिजाइन मेरे माइंड में नहीं था. अगर मेरे माइंड में होता तो मैं शायद पहले ही बना के देता. Okay, and still with the help of this approach, I have only proof two input and two output. Now अभी ये दो बाकी हैं. These two outputs are left. Okay, and अगर ये दोनों आउटपुट इस सर्किट पर काम कर गए तो you have designed something unique. Okay, otherwise if it is not going to work these two output or these two input with output on same circuit, then you have to think different combination, different hit and trial. Okay, different hit and trial. Again, there is a rule, no shorting. See, I have not done any shorting here, right? I have not done any shorting here. Very simple. Earlier the logic has been designed with the help of shorting. Okay, this is called shorting. This is called shorting. Okay, this is called shorting. This is called shorting. Okay, so we have to design our own gates without shorting. Okay, let's make the same circuit here again. Okay, A and B out. Okay, now I will take 1 0. 0 0 has been proof here, 0 1 has been proof here. Now I will take 1 0. 1 0, right? 1 0 1 1, this become 0, 1 become 1. Okay, same hai na? Okay, now this become 0, this will become 1, right? And this 1. See, wow, finally I proved the third one also. Believe me, this was not planned. Okay, this was not planned, right? This was not planned. The third one is achieved. Now let's go for the fourth one. So how many gates? 1 2 3 4 5. Okay, now let's start. Okay, now let me, where should I make? Okay, I am writing, I am making the fourth circuit here. Okay, right, same like this, NAND. This is the third one. This is the fourth one, and this is the fifth one. A and B out. Okay, now let me choose this color, this color. Okay, again, maybe we will again verify it. Okay, but before that, let's make this fourth one. One one. Okay, 1 1 1 1 0. 1 will come here. 0 1 will give you 1. This 0 will go here. This 1 0 will give you 1. This 1 and 1 will give you what? 0. And this 0 and 0. Wow, we got our fourth output. I am very happy today, okay, because believe me, okay, I taught so many times, but now today a God is with me because at this platform I was worried ki whether I would able to explain it or not. But believe me, I am very happy today ki yes, finally the first time I able to make the circuit randomly. This is called hit and trial. My dear, this is called hit and trial. Okay. In your presence, I am able to make it this circuit. Now the question is that someone will design the NAND gate, AND gate with help of 5 gates. Someone will take 6, someone will take 7, someone will take 8, someone will take 9, or someone can design the logic with the help of only 3 gates also, or 4 gates also. It's all depend on how you are thinking the, or how you are making the logic. Okay, so this is called a logic building. This is not end here. Okay, why? Because today I have made it in my first attempt, uh, AND gate with help of 9 gates. Again, verify it. Maybe I am wrong. 0 0 1 0 1 1 1 1 0 0 0 1 1 1 1 0. This is correct. 0 1 1 0. This is 1 1 1 0. This is 1 0 1 1 1 again 0. This is correct. This is also correct. This is also correct. Okay. So what you have to done here? Well, sorry, what you have to do here, my dear friends? What you have to do here? You have to follow the same approach. Okay. If you are in first year, if you are in second year, if you are in third year or in fourth year, don't worry about anything. Take a pen, take a paper, a blank, write a truth table of AND gate, output of AND gate, then NAND gate. Okay, and start designing this the gates of now OR gate. Now think about OR gate, think about XOR gate, think about XOR gate, think about XNOR gate. Okay, then think about even NOR gate with help of NAND. Okay, so design all these gate with the help of NAND. ओके एक बार बना के देखो, बहुत मजा आएगा. बिकॉज मजा कैसे आएगा? लोग बोलते हैं ना, यार मेरे सर से धुआं निकल रहा है, मेरा सर पक रहा है, मेरा सर बना रहा है. ओके, द थिंग्स यू हैव मे बी हैव हियर्ड विद योर फ्रेंड्स. ओके, व्हाई? बिकॉज यू हैव रियली यूज योर माइंड्स, ओके, टू डिजाइन समथिंग. आप देखो. ओके, सो start thinking of making the logic of AND or XOR, XNOR and NOR with the help of NAND gate, and similarly with help of NOR gate, okay, design AND or XOR, XNOR, XNOR and NAND. Okay, believe me, you will be called as an engineer. Okay, my objective is to think you like to make you capable to think like an engineer. Okay, we don't have to follow the notes approach. Ki I'm here to teach you something, to mentor you something, and I'm asking you to make a notes. No, we have to stop following this approach, because when you making the notes, when you writing the notes, you are not thinking. Okay, so whenever your college, in any college institute, anywhere, whenever your college mentor is teaching you or mentoring you, just listen him or her, right? Just listen him or her and try to find out something unique in that listening. What happened if this thing, what happened if this, what happened if this? Like in Hindi we say क्यों, why, ये क्यों आया, ये क्यों आया, ये किस लिए आया, ये कैसे आया. But nowadays what happened, you basically understand digital in terms of theory, understand digital in terms of writing the questions, understand digital in terms of clearing the exam. And that is why you are not called as a logical person. Okay, sorry to say, I'm not saying you guys, maybe you are logical, but every weekend I came across 4 to 5 new engineers, second year, third year, and I'm asking to do the same thing, but they never tried. But when they have tried this, they came up with a happy face, and I ask, so how you are feeling? So they are saying, sir, amazing, because they have designed something in this field, and that is called engineering. So what is engineering? In engineering, first step you will get failure, second step failure, third step failure. 9 times you will get failure, 99 times you will get failure, but one time will come and it will become a success. So same thing happened with me. Okay, today. So the first assignment I am giving to you everyone. First assignment. If you really appreciate our efforts, okay, if you really appreciate our efforts, okay, then please go to your home, take the notebook, take your pen, and start solving the start developing the gates without shorting. Okay, कुछ भी आए कैसे भी आए आपको करना है. पहले एंड गेट अचीव करना है, फिर नैंड गेट बनाना है, फिर नॉर गेट बनाना है, फिर एक्सऑर बनाना है, एक्सऑर बनाना है. एंड इफ यू आर अ ग्रुप ऑफ 4 5 6 7 फ्रेंड्स, डोंट गो एंड सी व्हाट ही इज डिजाइनिंग, जस्ट कंपेयर इन द लास्ट. यार आपने कितना गेट लिया? ओके, आई टुक 8 गेट्स, you took 12 gates, he or she took 13 gates, absolutely fine. Okay, so this is one thing from our side. Okay, now there are few more things, which I want to explain, but today I'm not going to take up, because that will take time. So what I want, I will take a next class on Wednesday, same time. Sorry for today, for 5 10 minutes we lost due to some technical glitch. Okay, but in next class I will be coming up with more this type of logical questions. Okay, where you have to think like as an engineer, where you don't have to think like as a theory person. Okay, there are many things, like just I will give you a small glimpse. If we have solved our NAND gates, with the help of NAND gates and NOR gates, the how to design the different gates. In future or in next class, there are few more gates which also act as a universal gates, but they are not exactly NAND and NOR. Okay, so we call universal gate only NAND and NOR. No. Now my question is to the person who is coming for interview. I ask, what are the other gates which is not a universal gates, NAND and NOR, but which act as a universal gates? Okay, so again the question is, we have learned only this NAND and NOR is a universal gate. Okay, yes, these are the universal gate. With the help of NAND and NOR we can design anything. Okay, we can design anything, but yes, there are 2 3 more gates like this which are useful in developing some other gates, that we are going to discuss in Wednesday. And if we will get a time on Wednesday, we will help you to think more logically with some black box approach. Black box approach is basically uh, developed by us only. Okay, black box, I am not going to tell you today. In the next class, I am going to tell you the black box approach. Very, 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 very interesting topic, black box approach. Right? Again, if you are really love digital, or you really love electronics, or you really want to become a VLSI engineer or embedded engineer or hardware engineer, anything, believe me, you have to start thinking like an engineer. Okay, you have to start developing the concept and convert those concepts into a logical. Okay, so next class I am summarizing. Next class I am going to tell you other than universal gates NAND or NOR, there are gates which are act as like a universal gate, but they are not exactly like a NAND gates logic, right? Second, I will teach you the black box approach. I will give you some logic and you have to make the circuit. And again, this is a really a very what I say brainstorming session. Okay, so from here, I'm going to summarize this session and thank you for joining. If you have any doubt, any concern regarding the uh, previous quiz basically, see, this is the first time we are working. Okay, why? This is not like we have repeated so many classes, we have taken so many classes, so we are also learning. Okay, so we have taken the quiz based on your three attempt. The person who has attempt all three and score minimum 75% will get a certification. Okay, why I am giving certification? Because you people are asking. So that is why I decided not to give you the certificate directly. We will take the quiz, and in that quiz the time is limited, and that quiz will be open for one time frame and you have to solve it. Okay, and you cannot give a second attempt or third attempt. Yes, we have given initially, but now we have decided not to give any second attempt, third attempt. Okay, so you have to score minimum 75 and you have to attempt all quiz, then only you are eligible for the certificate. Now the same thing will be, we are going to follow in digital. See, already we have done, networking is going on, sorry, network class is going on, and same thing we will follow the in digital also. So here in digital, what we are going to learn, we are going to learn basically, this session is totally project based session. Okay, I will help you to design some project with help of digital components. Then like a digital components, then how those digital components can be designed with help of HDL, that is called Verilog and VHDL. Okay, and then after the VHDL, you have to implement your logic on FPGA. So अगर आपके नॉलेज में ये सब चीजें आ गई, इन आपके रिज्यूमे में ये सब चीजें आ गई, योर रिज्यूमे विल नॉट लुक लाइक अ नॉन टेक्निकल रिज्यूमे. Okay, your resume will look like a professional resume or a practical resume. Okay, so be with me. Okay, take out some time. Don't believe in taking the offline classes. Come and join the online classes. This the online class will always give you the different impact. Okay, so this is all from my side. Let's meet on Wednesday, 6 p.m. Okay, so thank you everyone. Enjoy your life and be disciplined, be honest. This is my Guru month. Be disciplined, be honest. Whatever you have decided, please do it. Take the time. Try to finish the things. Don't jump. Okay, try to finish the thing. Jump, close it, then move on the second part. Okay, so this is all from my side. Thank you very much. Jai Hind.